Okay, let me introduce the next speaker. The next speaker is Dr. Toshiya Nakakura. He's a senior researcher at the NTT Communications, Japan. He's also researcher at the Keio University, Japan. And he led the team Synapse in the ANA AVATAR XPRIZE. So his talk title is the development and the deployment of the telepresence system in data centers. Okay, if you're ready, please start.
Okay, wait a moment, please. Okay. Hi, everyone. I'm Toshiya Nakakura. I'm a research manager at NTT Communications, and NTT Group is the biggest telco in Japan. Today, I will talk about XR robotics from the perspective of commercial implementation attempts at Japanese telco. Today, the content that I will present today includes the results of the Tokyo Robotics, which is our joint research partner. Okay. Actually, we have not yet successfully finished commercialization of the XR robots, but still, so we believe we have high-level engineering skills, and we will explain how Japanese telco are trying to overcome the gap. Okay. Okay, so what's the relationship between robot and the XR device and network? The network is a link between the robot and the XR devices worn by pilots. And the network consists of many devices. In the network, delay occurs in the process of many network devices, and the delay is not constant and varies from time to time. So this factor must be considered. The factor is called jitter. And yeah, usually robots are connected to wireless networks, so often some packets often be lost. We are considering the aspects, and yeah, we are now trying to deploy the robot to the data center. Okay, in the data center scenario, a small failure can cost engineers. For example, a small failure on the server at the data center force engineers to, how can I say, several hours travel to the data center all the way. And it is a waste of time. So we tried to solve the problem with a robot. This is the first trial in 2019. I controlled the robot and tried to open the rack and plug a console cable to the server. Yes, I succeeded it. Okay, it works well as a first attempt, but I faced many problems. Yeah, when I operated, I had a hard time getting the door shut. It's because of the delay and the lack of haptic feedback. Without haptic feedback, sorry, the knob of the data center rack had to rotate with the door properly closed. But without any haptic feedback, I cannot understand whether the door is properly closed or not. So I had to check all the sequence by vision. So I check the door, properly closed, and find the knob and turn the knob. That was really stressful. So I asked Tokyo Robotics to create a technology to send, how can I say, force feedback. The left arm is considered as a remote robot, and the right hand is the operating system. Operator can feel the softness of the rubber ball in real time. It worked very well in the local network, but how can I say, it was difficult to use it over the internet. It's because of the howling. In such kind of system, in such kind of bilateral system, it is known that delays may cause howling even if it's the force. So we deployed basic technique impedance control to mitigate the effect. Yeah, it works well basically, but the more, how can I say, the larger the delay, the more stiff spring content we have to use. So operator cannot feel the subtle change of the force feedback. Okay, so that can I say, yes, that's a reason, how can I say, yes, thus the network affects the force feedback and for perception of the force. Okay, how much latency in the real network? I calculated, and it was 25 milliseconds between Tokyo to Sapporo. Sapporo is the northmost city in Japan. And it was 200 milliseconds between Japan and the US East. And it takes 106 milliseconds between Japan and the US West. According to the result, I had to say that our bilateral system is hard to use over the international connections. But we found that our system can work within Japanese networks. So we shot a joke movie to promote our technology. The operator can feel the, how can I say, weight of the dumbbell, and he can do muscle training through the system. And the robot actually sends feedback, so the operator gets tired after the video shot. Okay, now I will mention about the jitter, effect of jitter. Jitter is, how can I say, not stable delay, changing delay. So it means some packets come earlier than the other packets. So it makes the gap between vision and haptic sensation. The gap is called cross-modal gaps. And if vision packets come later than haptic packets, operator feel haptic packet, how can I say, that doesn't match the vision in his HMD. So the haptic sensation lose the meaning in the case. And that's, how can I say, yeah, that's just confuse the operator. Okay, how much degree of the gap is acceptable? We surveyed many papers in psychophysics areas, and we finally the result. The paper said 35 milliseconds is, how can I say, is the limit to user, how can I say, notice the gap. 35 milliseconds is too small. It means just 2 frames with 60 FPS video. And if you use 30 FPS video, it's just a frame. Okay, so can actual networks support the use case? I surveyed the 4G statistics in Japan, and it shows in overcrowded areas like Shinagawa Station, the jitter is too large to use haptic system. And yeah, crowded area means, how can I say, downtown. So it is likely demand of the XR robots, but I had to say it is really difficult to deploy the system in the downtown now. And yeah, you may think it's the result of 4G, but 5G will show the same pattern. It's because 5G is also depends on the time sharing system of the radio waves for users, between users. As for the Wi-Fi, I measured Wi-Fi heat map in our data center. And in our trial, we found that a robot 4 aisle away from the access point, it makes a large cross-modal gap. And to mitigate such kind of gap, the basic method to mitigate the gap is to use RTP packets to, how can I say, to buffer the packets and play it in order. But it is difficult for, how can I say, it is difficult, really difficult to deploy the system because the engineer have to know all the aspects from hardware to software. If you buy sensors or haptic display or robot, that's a black box from you. And on the other hand, excellent hardware engineer who can implement sensors and robots, not always, how can I say, not always familiar with the network part. It is the root of the difficulty of, how can I say, of develop, how can I say, oh, sorry. It is the root of the difficulty to develop XR robot systems. But you may think, but vision and audio is synchronized very well in the basic system. Yes, it's true. And yeah, it's because of the standards. And vision and, how can I say, synchronizing vision and audio is standardized in TPAC and IETF. So, but haptic, how can I say, there is no standard to synchronize haptic and vision. So I reported the use case of, how can I say, the difficulty of the cross-modal use case in the XR robotics at TPAC. And due to the, how can I say, same kind of request from game industry, they started developing the standard to synchronize vision and data. Also, I will share my implementation of WebRTC system. How can I say, my implementation my implementation of network engine for XR robots as a loss package by the end of this year. And okay, as for the business part, there are many problems, but it's really simple to understand. That's two factors, cost and concern about the latest technology. Yeah, almost, how can I say? Yes, after all, humans are more cost effective than robots. That's and yeah, part-time workers, especially in Japan, works for work diligently and do variety of tasks only for $15 per hour. But on our robot cost $100,000, so it's the biggest problem to commercialize. And so we need to deploy the robot in the very limited area in the realm of skilled workers. And this is the robot we create. Yes, it sensed the rack and it can open the rack and plug a cable to the servers. The task itself is really easy, but it cannot, how can I say, it cannot do with part-time workers. It's because they cannot make sure that they can do proper tasks to proper devices. So many users, how can I say, start thinking to use this system. And we also offer the low-price robots in our business. And we, how can I say, this is a really simple telepresence system to monitor the server status with vision and audio. And we dare to use line trace system instead of SWAM. And it is because of the demands of our customers. Okay. And yeah, and that's all about my explanation. And I'm, how can I say, it is necessary to collaborate with many people and many field of engineers to make realize XR robots. And I believe I can share the information and our skill from network areas. So I'm happy to, how can I say, I'm appreciate if you're interested in my speech, and if you collaborate with me, yeah, I'm happy to do. Sorry, I'm happy to collaborate with you. So thank you.
Thank you very much, Dr. Nakakura. Are there any questions? It's okay. So you can ask questions in the industry panel discussion later. So let's move on to the next speaker. Thank you again.